So welcome to Lesson 5, Trigonometry of Angles. Today we are determining the measure of two angles from 0 to 360 degrees for which the given trig ratio is the same. And really what this is just solidifying your understanding of what we've done the last couple of lessons. So for our first example, we have for tan theta equals negative 7 over 24, where theta is between 0 and 360 degrees. In which quadrant is it possible for theta to terminate? So remember, for that, we're just looking for that terminal arm where it will end, okay? So we know that since tan theta equals y over x, we learned that in our second lesson, then tan theta equals negative 7 over 24, given in our question, then y over x equals negative 7 over 24. So this actually gives us two possibilities, x equals 24, and y equals negative 7. Or you can put that negative with the x with 24 and make the y positive 7. Okay, so you're actually going to be given two possibilities. Our very first one, we're going to just draw it in the Cartesian plane. So if you were to draw that point, 24, negative 7, that's where you would put your point. And then you know that that angle theta is going to be in quadrant 4. This is quadrant 4, remember? As well then, let's draw this ordered pair, negative 24, positive 7. Negative 24, positive 7, that is going to be in quadrant 2. So you know that you're going to have an angle that terminates in both quadrant 4 and quadrant 2. However, you really could have done this without drawing those ordered pairs, because you know that tan is going to be negative. From using our cast rule, our tan can only be negative. Tan is negative in this quadrant. Wow, I don't know why that didn't write, sorry. And tan is also negative in this quadrant. Sorry, this is lagging. Okay, and that's same with this one. Okay, so you know that they're going to be negative there. All is positive tan and the t is positive tan, so it couldn't be in those two quadrants. Okay, next part of the question, determine the other primary trigonometric ratios for theta. There are two possibilities, x is 24 and y is negative 7, or x equals negative 24 and positive 7. So you know that for xy, so your point xy, it's going to be 24 and 7. So you know that here, if you were to draw that, 24 and then that negative 7, you know that this is 24 and you know that this part is 7, but you don't know that r. So that was what you're going to find out by doing Pythagorean theorem. So take the square root of 24 squared plus negative 7 squared. And then that's 576 plus 49, and then square root it to be 25. So then you can set up your other ratios. Sine theta is y over r, so it'd be negative 7 over 25. And cos theta equals x over r, so it'd be 24 over 25, because you know that this is x, this is y, and this is r. So you can set up your three primary trig ratios that way. However, you do have to do the exact same thing for your other point here to that 24 and the positive 7. Sorry, negative 24 and positive 7. So it's going to be the exact same because this is in brackets, and whenever you square something in brackets that's negative, it's going to be positive anyways. The only thing that it does here is you'll notice the sign is negative 7 over 25 for your first ordered pair, but it's actually positive here for the other ordered pair. Okay, so really they are the same, it just has switched negative signs, which isn't a big deal. Okay, and then we're also going to evaluate theta to the nearest degree. So what we're going to do is select any of the trig ratios to determine the measure of theta. So using sine of theta equals 7 over 25, it's easiest probably just to use sine, it's the first one that you think of. Then you're going to take the inverse. Remember, you have to bring it over to this side, and to bring it over to that side, you have to take the inverse to solve for an angle, and then it is going to be about 16 degrees when you put that in on your calculator. Okay, however, wrote on that. Clearly, you know if you know anything about angles, 16 degrees is definitely not in quadrant 4 or in quadrant 2, right? So if you were to, oops, don't want the highlighter, want my pen. If you were to draw 16 degrees, clearly you know that 16 degrees, ooh, I don't know what happened there. 16 degrees is in, what, pen, sorry. There we go. So it's not in the first, it's in the first quadrant. It's not in quadrant 2 or 4. So you know that it actually is the related acute angle in our second quadrant and in our fourth quadrant, okay? So when you draw it here, you know that that's 16 degrees. So you're going to do 180 degrees minus 16 degrees to be 164. And you also know in quadrant 4, you're going to just take that 360 degrees minus 16 degrees, 344. So this is nothing new for you. The only difference was that we took an actual primary trig ratio, solved it to get our related acute angle, and then we were able to find our actual principal angle. So you know how to do that for each of the quadrants. Okay. For this second example here, we're going to find all values theta if theta is between 0 and 360 degrees. So our first example, we're looking at cosine. So we have the cos of theta equals cos of 250 degrees. So we know that one of our values of theta is 250 because that's between 0 and 360, but we need to find that other value theta here. So we are going to first draw our angle of 250 degrees. So you know that that angle is 250 degrees. Oops. Okay, and then you are going to find your related acute angle here. So you know how to do that. Lots of practice with different examples. So you're going to take 250 degrees, and you're going to subtract 180 degrees, which is going to be 70 degrees. So you know that you have a related acute angle of 70 degrees. So now we're going to use that to our advantage, and we know that there's going to be another angle with a related acute of 70 degrees that is also going to be negative in our, because its cosine is negative in our tan quadrant. So we need to find out where else cosine is negative. So you know it's not negative in the cos quadrant, you know it's not negative in the all quadrant. So you do know that it's going to be negative in this sine quadrant. So you're going to draw your related acute of 70 degrees, and then you're going to find that principal angle theta. So theta is going to be found there. You simply are going to take theta and you're going to do 180 degrees, subtract that 110 degrees, subtract 70 degrees, I just gave you the answer, subtract 70 degrees, and then you are going to get 110 degrees. Okay, so therefore theta is equal to 110 degrees. So you know that theta would be 250 degrees. It was already given to you. The other angle is 110 degrees. Okay, same thing for these next couple examples. So tan is 130 degrees equals tan theta. So we know one of the angles is 130, but we're going to find that second angle. Our second angle is going to be found using that related acute again. So draw your principal angle of 130 degrees. Find that related acute. So your related acute is going to be 180 minus 130 degrees, which is equal to 50 degrees. So you know that this is 50 degrees. We are looking at tan. Tan is negative in that sine quadrant. So where else is tan negative? It's going to be negative in this cosine quadrant. So you're going to bring that down, and you know that your related acute is 50 degrees. Then you're going to find theta the exact same way, but this time it's easier to go 360 minus this 50 degrees, which is 310 degrees. So therefore, theta is equal to 310 degrees. Okay, same thing again. We've been through examples like these, so they should be somewhat making sense. Okay, so going from sine negative 200 degrees equals sine theta, we're just going to, because that negative's there, we're going to draw backwards that 200 degrees. So go back 180 degrees and then up another 20 degrees. So that is going to be your negative 200 degree angle, okay? But remember, this time we are not allowed to have our one of our angles be negative, so we're actually going to find two principal angles because we have to be between positive 0 and 360. This is negative 200, okay? So we're actually going to find two principal angles. Your easiest, again, find your related acute. So related acute is going to be 200 degrees minus that 180, which is going to be 20 degrees, okay? So you're going to find this positive angle here first, so I'll just draw it in red. You're going to find that principal angle, because remember the negative 200 is not your principal angle because it's not positive. So you're going to find that principal angle. So theta 1 is going to be marked here. It's going to be 180 degrees minus that 20 degrees, which is going to be, sorry, my pen is being weird, which is going to be 160 degrees. Okay, so one extra little step compared to here because we had that negative angle to start. But then we're going to find our second theta. So sine, we're looking at sine. Sine is positive in the sine quadrant. Where else is sine positive? Sine is positive in our first quadrant. So you're going to draw it here. You know that you have a related acute of 20 degrees. So your other theta 2, no math here, is going to be 20 degrees. Okay, so those are quite similar questions. It's the same steps every time, and we have looked at them before. Okay, so you should just remember that you're going to continue to do the same thing over and over when you see questions like these. For example number 3 here, we have that the cos of theta is equal to 0.5, and we want to figure out what it is, the angle theta between 0 and 360 degrees. This time though, we're not given an angle to be able to draw like easily on our Cartesian plane, just like our last examples. So instead, what you're going to do is you're going to remember your special triangles. Remember 1/2 is equal to 1/2. And your special triangles, just remember you have your one special triangle that is 2, 1, and root 3. And then this is 60 degrees here, sorry. And then this is 30 degrees, okay? You also have your 1, 1, root 2, but we don't need a root 2. We need a 1 and a 2 here for this cos of theta. So if you were to actually draw this on your Cartesian grid, actually I think it's going to draw this for us. We know that this is 2, this is 1, and this is root 3. And we are looking for the cosine. So cos is adjacent over hypotenuse. So that angle theta is going to be 60 degrees. I'll erase that. Sorry. Okay, so it's going to be 60 degrees because of your special triangle. However, that is theta 1. Come on. There we go. That is theta 1, but you do need to figure out if there's more than one positive cos, which you know that there is. So where else is cos positive? It is positive down here in our fourth quadrant here. So you know that you can also find another angle. So make sure that you are thinking of all the other possibilities. What other quadrant is it possible for this solution to be in? So it is going to be in that fourth quadrant as we just talked about. And then what you're going to do is just find that second theta. Remember that that is just going to be 360 degrees minus the 60 degrees because that's your related acute, and that is 300. Okay, so it's the exact same thing other than starting this terminal arm here. We had to remember back to our special triangles because we were not given an angle, sorry, stuttering over my words there, okay? For our next couple examples here, these are going to be tricky because you do not have these as part of a special triangle. So what we're actually going to do is just take the tan inverse to get to know what theta is. So you're going to take the tan inverse and you should get negative 67.8 degrees. And then you're going to draw that on your Cartesian grid to give you that terminal arm. Remember that you're going to have to find that principal angle. It can't be negative. So you're going to take 360 degrees and you're going to subtract the 67.8 degrees. So you get one of yours angles is 292.2 degrees. But then you have to remember where else this is. We're looking at tan. Where else is tan? Negative, because it would be negative in the cosine quadrant. It would be up here in quadrant number 2 in our sine quadrant. So you're going to draw that one as well, and then you're going to have to find that principal arm. Okay, so it's going to be 180 minus the 67.8 to give you 112.2. So you have two answers for theta there. Okay, same thing again. Take the inverse cos of negative 0.812, which is going to be 144.3 degrees. Draw that on your grid. That's going to be your first theta. That is your first theta. Okay, you don't have to do any math because it wasn't a related acute angle where this one was, and it was also negative. Remember, negative can't be here, but this one's positive. It gives you that terminal arm. So your first theta is 144.3 degrees. Where else is cosine? It's negative in sine, so where else is it negative? It's going to be in the tan quadrant. Find out that other principal angle. To do that, you're going to take 360 degrees minus 144.3 degrees to be 215.7 degrees. Okay, so a lot of those examples were all the same. They're just a couple little tips and tricks for those ones. So what you're going to do is complete page 9, 1 to 6. Make sure you're just doing ACE and E, and 7 to 18, and then you're also going to complete a handout. Okay, good luck. Let me know if you have any questions.